Hello all, this is Mr. G and welcome to Beating the State Test Round 2, Function Notation and Transformations. In this video, we're going to be taking a look at all of the released items, the released questions from the most recent state tests that have to do with function notation and function transformations. Before we take a look at the questions we're going to be doing in this video, let's make sure we remember what we need to know about this topic so we can answer these questions correctly. So what do we need to know? When we're talking about function notation, we're talking about a function written in this form. F of x equals something. Now this letter here, F, standing for function, doesn't have to be an F. It could be a G or an H or almost any other letter. So if you ever see a different letter there, don't let that throw you off. It's just function notation. Now let's say it's f of x equals 2x plus 5. We'll keep it simple. And then there's a few different things we can do with this. We could have maybe, instead of f of x, they could change it to f of 3. And what that's essentially telling us when we see this is that, oh, 3 is our x value. So we just rewrite this expression, but instead of f of x, it's f of 3. So wherever we see an x, we write 3. So 2 times x plus 5 becomes 2 times 3 plus 5. And then we can simplify that. 2 times 3 is 6, plus 5, and we get 11. So that means when we give this function, f of x, a 3 for the domain value, it spits out an 11 as the range value. But they can give us other things to substitute in instead of just a number. Like, for example, say they gave us f of x plus 2. Well, basically that's saying, okay, instead of an x value, we want this function for x plus 2. So we look at our original function, 2x plus 5, and we do the same thing we did here with the 3. But instead of substituting in a number, we're substituting in an expression, x plus 2. Let's take a look. 2x plus 5 becomes 2 times, what do we write instead of x? We write x plus 2. So it's 2 times x plus 2 plus 5. And then we just simplify. Well, 2 times x is 2x. 2 times 2 is plus 4. And plus 5 comes down. Then we simplify that to get 2x plus 9. So here we ended up with an expression, which shouldn't surprise us because we plugged in an expression. So we should not have expected a numerical value. So that takes care of function notation. But what about function transformations? Well, that really has to do with sort of the parent function, the most basic form of a function, which I'm just going to write as y equals f of x. Now, when we're talking about a transformation, the transformation form would be y equals f of x minus h plus k. Now, hopefully this looks pretty familiar if you've seen vertex form of a quadratic before, but in case you've never seen that, I'm going to give you a quick crash course in what this means. This k value right here, this is basically talking about our vertical transformations, our vertical translations. So, okay, if k is a 5, like if we see a plus 5, that means we go up 5. And in case we ever see like a minus 5, if we change that to a minus 5 after the function, well, that just means we go down 5. So vertical transformations pretty much work the way you'd expect. If we see a plus 5, we go up 5. If we see a minus 5, we go down 5. But that is not what we see inside the parentheses here, because this H stands for the horizontal translations going left or right. And if we saw a plus 5 in there inside the parentheses, we would probably think right 5, but we actually do the opposite and go left 5. And likewise, if we saw a minus 5, we usually think, oh, negative numbers, that's going to the left. But if it's inside these parentheses, it works the opposite and we would go right 5. So you always want to be more careful when you have an addition or subtraction inside the parentheses when you're dealing with function notation, because you're going to be moving in the opposite direction of what you'd expect. Plus 5 moves you left, minus 5 moves you right. Now, there's one other transformation I want to talk about before we jump into our examples, and that has to do with, well, what if we had something like this? Y equals negative f of x. So we're not adding or subtracting here, we're throwing a negative in front of the function. What would that do? And the easiest way to explain this is to work with y equals x squared. So if we had x squared, hopefully we know that shape, that would be a parabola, a concave up parabola opening up. But if we had a negative x squared, well, that would be this same parabola, but reflected upside down. So if we ever see a negative in front of a function, that's just saying, okay, take the original function and reflect it vertically, essentially reflect it over the x axis. All right, that's enough setup. Let's jump into our first problem. Number one says, given that f of x equals 3x and g of x equals x plus 1, complete the expression for h of x if h of x equals 2 times f of x squared minus 3 times g of 6. And we've got to drag and drop the expressions into each box. We've got a bunch of expressions here to choose from, and those are all going to go in to fill these blanks. So it says h of x equals 2 times blank minus 3 times blank. Those are the first blanks we have to fill in. And looking at that, that looks very similar to what we see up here with h of x equals 2 times f of x squared, because it's 2 times something. So this blank is going to be f of x squared, and then it's minus 3 times g of 6. So that g of 6 is going to go down there in that first blank. So let's take a look at the rest of these directions and pull out some important clues. So, well, this f of x equals 3x, that's obviously going to be important. And likewise with this g of x equals x plus 1. Let's start with this g of 6, because I'm betting that's going to be the easiest place to start for most students. So g of 6, they're giving us g of x is x plus 1. So, all right, g of 6, we would just take this x plus 1, and instead of x plus 1, it's 6 plus 1. And then 6 plus 1 is just 7. All right, so that first blank is going to be 7, so we can drag a 7 down there. Now let's take a look at this f of x squared, because that's going to be the first blank we have to fill in. Well, okay, so f of x squared. Obviously, we're going to be using the 3x here, because that's what f of x equals. But here they're giving us an x value, a domain value, an input value of x squared. So we're going to rewrite this 3x, but instead of 3 times x, we're going to put 3 times x squared. Well, that's just 3x squared. And is that one of our choices? I can't find it just yet. There it is, 3x squared. So we can drag that down. And then to get these two blanks down here, we just essentially simplify. So 2 times 3x squared, well, 2 times 3 is 6. So we need 6x squared. And 3 times 7, that's 21. Do I see 21? It's right there. And we can check the answer. And that is exactly right. So number one is complete. Number two says, consider the function f of x equals log of x. Which two transformations can be used to move the graph of f of x to the graph of negative f of x plus 4? Select all that apply. And then we've got a bunch of choices here, some translations, some reflections. Let's take a look at the important clues first. One thing I see in the directions that is actually a complete distraction is this log of x. We don't need to use that at all to answer this question. The clue that we want to focus on is right here, negative f of x plus 4. And that's essentially using this formula, f of x minus h plus k, to tell us where we're translating our original function, our original f of x. Well, if I look right here, x plus 4, that's inside, so that's our h value, and there's no k outside. Now remember, k was a vertical translation, so this function transformation is not being translated up or down, so we can immediately cross off a and b. We're not going to choose them because we see no k value. There's nothing being added or subtracted outside of the parentheses in that function notation. But there is something being added inside. And inside, remember, this h controls horizontal movement, so moving left or right. And what we have to remember is that inside the parentheses, we do the opposite of what we'd expect. When I see a plus 4, I would think, oh, that's going to the right 4. But since it's inside the parentheses, we do the opposite and we go left 4. So C is one of our choices. Translate 4 units to the left. Now, the only thing we have not used yet is this negative in front. And we remember a negative reflects over the x-axis because remember, an x squared is concave up, but a negative x squared would be concave down. It reflects it over the x-axis. So our answers should be C and E, and that's what we see. Excellent. And that's the end of this video. As always, I hope this was helpful. If you have any questions, let me know. Enjoy the rest of your day.